In this video, we are going to get introduced with the derivative. First, what is the power rule? If a function of x is x to the power of n, where n is a real number, the notations of derivative of the function is d of f of x, the function, by dx equals the exponent n times the base x with a new exponent n minus 1. We are not going to use this notation. Instead of that, we will work faster with f prime of x. D of f of x by dx is the same as f prime of x, which is n times x to the n minus 1. Now one more time, f of x is x to the n. D of x of n equals n times x to the n minus 1. That's the formal narrative, but we will have a new strategy applying the power law. When we are given f of x with exponent, f prime x, we will write the base x, put the n on the left, new exponent n minus 1. Write the x, put the n on the left, new exponent n minus 1. See how easy it becomes. First example, what if f of x is x to the 9? So n is 9. F prime of x, write the x, put the exponent on left side is 9 times x, the new exponent 1 shorter, 9 minus 1. Simplification is 9 times x to the power 9 minus 1 is x to the 8. Another example, what if f of x is x to the 4, where n is 4? F prime of x is, write the base, put the exponent on the left side is 4 times x, the new exponent is 1 shorter, 4 minus 1. Simplify, is 4 times x to the power of 3. And we are done. Okay, we do more example on this page. On the top, we have got the backup formula, the power rule formula on the top. So what if f of x is x to the 15, n equals 15? F prime of x, write the base x, the 15, write it on the left, 15 times x, exponent 15 minus 1. Done. Simplification is going to be 15 times x to the exponent of 15 minus 1, 14. One more example with a negative power. So n is negative 7. F prime of x is going to be, write the x, negative 7 is the coefficient of x, negative 7 times x, exponent, negative 7 with a negative 1. Done. Simplification, the negative 7, negative 1 simplifies to x to the negative 8. But by exponent law, the negative x to the negative 8 should move down and become x to the power of positive 8. So negative 7 stays on top. This goes down with the power of positive 8. What if x to the power of negative 1 has to be, the derivative has to be found? So f prime of x, write the base x, negative 1 comes in front, exponent is negative 1 with a negative 1, so it will be negative 2. So simplification is negative 1 times x with negative 2, x to the negative 2. I just wrote the 1 just to understand. We don't need the 1. Now, it will be a negative value, but on the top 1 will be there. By the exponent law, x to the negative 2 will move down with x to the power of positive 2. That's the final answer. Now, we will take a definition from here. Let's try with what is derivative of x. So f of x is just x. The invisible power is 1. The power is not written. So if we see x, if you have to find f prime of x, the invisible one, write the base, invisible one comes on the left. Exponent will be the invisible one, write it with a negative 1. Basically, it's going to end up with 1 times x to the 0. X to the 0 is 1. So the final answer is 1. Now we learned something from here. What if it was 4x? What if it was 10x? If it was 4x, the answer would be 4. If it was 10x, the answer would be 10. Because finally, it will be the 4 times the result. This x0 is going to turn up as a 1. So 4 times 1, 4. 10x, 10 times 1, it will be 10. Done. In this page, we just go through the quick notations. Some of the notations will be written in the book. Formal derivative notations, dy dx, which is derivative of y with respect to x. So when y is f of x, d of fx by dx, derivative of fx with respect to x, we just use the shortcut. So instead of dy dx, we will just use y when y is dy dx. Sorry, when y is f of x, dy dx, df of x by dx is y prime. Y with that symbol, that's the derivative. And when we have derivative of f of x, we will just use f prime of x, which we have been doing for the last 2 or 3 examples. So this is a very important, and there is a very important relationship of limits, derivatives, which is coming on the later part of this calculus series. In this page, we are going to learn how to handle coefficient. So f of x, k times xn, d of k times xn by dx, it will be the k, the constant, times the derivative of the xn, which you have been doing before. So first, function of x, x to the power of 0. Basically, if you know x to the power of 0 basically is a 1. So indirectly, what is derivative of 1? So derivative of 1 in algebraic way is x to the power of 0. Write the x, put the 0 on the left side, 0 times x is going to be 0 minus 1. Doesn't matter what x exponent is, this 0 is going to make that value 0. 0 times anything is 0. So instead of 1, sorry, x, if it was a 1, it would have been also a 0. Now from there we go to the next step with a number. We learn basically it's going to be 5 times x to the 0. So derivative of a constant is 0. Derivative of any number, any value, decimal fraction, as long as it's a constant, f prime of x is 0. Now let's have something with the coefficient. 5 times x to the 4, where the exponent is 4, f prime of x. 5 will be sitting in front. We have to deal the derivative of x to the power of 4. So whatever the value turns up, 5 times the derivative of x to the power of 4. Finally, it's going to be 5. Bring that base x. The 4 comes to the left, and it would be x to the power of 4 minus 1. Finally, it's going to be 5 times 4, 20. X to the power of 4 minus 1 is 3. Just let's try to find a shortcut, isn't it? Second step, third step, the final step is 4 times 5, 20. Watch out, we are going to go there later. 4 times 5, or 5 times the 4 is 20. This, power 1 short. 5 times the 4 is 20. x4 is 1 shorter. We will use that strategy on the later part. Just a quick touch over here. Another example, a fraction times x to the 6 is going to be the fraction times derivative of x to the power of 6. I'm using the formal notations because of the introduction of the constant. So it's going to be 2 over 3. Derivative of x to the 6 is the base, the power. The base is base of what? This 6 exponent is base of x. X, 6 on the left, this x minus 6 minus 1. The one I'm mentioning, we are going there. There are some other parts we are going there. Just making some introduction over here. Finally, this value, the 6 divided by 3 is going to be a 2. Is going to be 2 times 2, 4 times x to the power of 5. And that is our final answer. In this video, we're going to learn the addition rule. F of x has 4 terms, x to the 5 plus x to the 3 minus x to the 2 plus 8. We have a constant. We have learned constant of derivative of constants at 0. So the strategy is f prime is going to be, we're not doing the derivative now, is going to be derivative of the x5 plus derivative of the x to the power of 3, subtract derivative of the x to the power of 2, add derivative of 8. That's the plan. Now finding derivative is going to be, as we know, base 5 goes to the left, 5 is exponent is 5 minus 1. I'm just using a very easy strategy. It feels easier to me and my students. Write the x, 3 goes on the left, exponent is 3 minus 1. Negative, take the base x, 2 goes to the left, exponent 2 minus 1. And derivative of 8 is 0. Once we write it properly, calculation, just simplify it, is going to be 5 to the exponent Sorry, that was 0. I forgot to click it. Now it's going to be 5 times x to the power of 4 plus 3 times x to the power of 3 minus 1 is 2 minus 2 times x to the 1, which is just, we don't need the 0. Another example, if f of x is 1/5 of 5, let's bring another one, 1/3 times x to the 3 minus 1/2 times x to the 2 plus 11. We have 4 terms. The last term, derivative of the last term is going to be 0. So it's going to be 3 independent derivative. So derivative of the first, derivative of the next, subtract derivative of the third, and derivative of the last term. Derivative of the first term is going to be the coefficient k times, write the base, this exponent comes to the left side, this exponent value goes to the exponent zone with 5 minus 1. 5 times x to the 5 minus 1. 1/3 is the coefficient, base is x, n comes to the left side 3, and over here is 3 minus 1. The last part is negative of half is the coefficient, derivative of x to the power of 2. Bring the base down, exponent 2 is on the left side, 2 times x, and it's 2 minus 1. And derivative of the number, any constant is 0. Derivative is done. Now it's time to simplify. 5 on the top, 5 down, 3 on the top, 3 down, 2 on the top, 2 down. All brings a 1. We don't need the 1. 1 times anything is 1. So it's just going to be x to the power of 5 minus 1, which is x to the 4, plus is going to be x to the power of 3 minus 1, which is x to the 2. Lastly, it's going to be negative x to the power of 2 minus 1, which is just a x. We don't need the 1. And obviously, we don't need zeros, and it's done. How to find derivative when the radical or second power of root or square root comes? It is power of 2 second power of root, so that means the invisible power of the root is 2. We just convert it using our exponential rule. So square root of x is x to the power of that 2 invisible is there, and the 1 inside part is there. We know how to do that. Before we have to start derivative, we should know that. So the exponent is half. So what will be f prime of x? We just learned, write the base, write the exponent on the left side, and the exponent, the original exponent, half minus 1. Now half minus 1 has a algebraic law. Let's finish the law by algebra, then I will show a shortcut. It's going to be that times 1, sorry, that subtract 1, we change the 1 as 2 over 2 to match the same denominator. So it's going to be half times x to the power of same common denominator 2, negative 2, negative 1 is a negative 1/2 or half. So this exponent should go down. So it's going to be half times 1 over x to the power of positive half. And that half notations can be converted again into the square root notation. So it's going to be half times 1 over that value square root of 2. We have a notation to learn whenever we are given that in the future. Multiply half times 1 over the whole value. We will use that as a notation. Half times 1 over, what about that? Let's just erase that value from there. Let's just block this part, because it's a long process, so it will be used as a notation. Half times 1 over whatever the value is given, write that value on in the denominator. That's the final answer. But obviously we have to go for simplification. It will be 1 times 1 on the top, 2 times square root of x over here. Now one more example of coefficient, 10x. F prime of x would be 10 times derivative of x. We know it's a 1, but still showing by the process is the base, the invisible 1 comes on the left, and the exponent is 1 minus 1. So it's going to be 10 times x to the power of 0, and x to the power of 0 is 1, so 10 times 1 is 10. So derivative of 100x, 20x, 50x, we just take the number. When it's just a x, no exponent, invisible x to the 1, derivative is just the number. One more example. Derivative of something with the power of something. we have a chain rule to do that, but this is too simple. Let's do it by the regular power law. Simplified. It's going to be 3 to the power of 2, 9, x to the power of 2 times 2, x to the power of 4 on the top, 2 to the power of 2 is just divided by 4. Separate the constant coefficient. So basically it's 9 over 4 times x to the 4. That's the simplification. Now let's proceed with derivatives. So f prime of x, sometimes organizing things is easier. It's going to be the yellow value 9 over 4 times derivative of x to the 4, which is write the base x, put the 4 on the left side, exponent is 4 minus 1. As simple as that. Now simplification. This 4 on the top, the 4 on the down is gone. That means it's a 1. So it's going to be 9 times x to the power of 4 minus 1, which is 3. And that's the final answer. Done. In this video, I'm going to apply the basic chain rule, which is a little complex. I have a separate video for chain rule, the complex problems. This is a very easy one. And let's update the regular power rule with the chain rule. F of x is xn. F prime of x is n times x with n with a subtract 1. Chain it by multiply it by the inside value. Remember the base. So is the x prime. What is the difference? So x prime on the right side means derivative of x. So just an example. What if we have derivative of, find derivative of x cubed? F prime of x is going to be, this is, I just do it in a normal easy way. So it's going to be 3 times x to the power of 3 minus 1. By now we know it's very easy. But what if I just show the chain law, but why the chain law didn't have any impact on the regular one? Chain law was not compulsory over here. This is the reason why. It was basically 3 times the base with a new exponent x minus 1, and that was the base. There was a chain law invisibly. Is we found the derivative of that multiplied by the derivative of the inside, and we know derivative of x is 1. So this answer is x to the power of 3, x to the power of 2. We have lots of examples. Chaining it or multiplied by the derivative of the inside, basically it was multiplied by 1. That's why that red part was not applied. But we should know at this time, after so many practice, there is something we are avoiding. It's not avoidable in the future. Now let's have a living example. On the left side, we did something like this by simplifying it. So let's simplify it. X to the power of 3 times 2 is x to the power of 6. What would be f prime of x? It would be 6 times x to the power of 6 minus 1. By now we know it's 6 times x to the 6 minus 1. It's going to be 6 times x to the power of 5. 6 minus 1 is 5. Let's apply chain law. Because every time it was the base x. Now the base was x to the power of 2. We simplified it. But before the simplification, what about if you want to find derivative of the way it has been presented? So the parenthesis value of power of 2. Derivative of x to the power of 2 is going to be 2. This 2 is going to impact this value if we just do it like this way. So f prime of x is going to be 3 times the derivative. So 3 times the base with 3 minus 1 multiplied by the derivative of the inside. The inside power was x to the power of 2. This value is 3 times x to the power of 2, which was the base. We didn't simplify it, with a power of 2 multiplied by the derivative of the inside again. So it's going to be 2 times the x with 2 minus 1. If we simplify, we should get back to the right side. Looks complicated. It's complicated because it's so simple. It's coming, we will need it. So the left side simplification is going to be 3 times x to the power of 2 times 2, 4. And it's going to be 2 times x to the power of 2 minus 1 is just the x. Finally, 3 times 2 is 6. And x to the 4 with x to the 1 adds up by exponent law x to the power of 5. We should learn the right hand side. See, this is the difference between regular power rule and power rule with the chain law. On the left side, we will do it by the regular power rule. On the right side, we will have another example that where chain law is compulsory. So it's a fraction. We use fraction law. It's a fraction with exponent. We use the exponent law. Is the base to the power of -2. Simplification now. What is the f prime of x when is a base value with the power of -2? This is as simple as 2 times the base with the power of -2, -1. I didn't write the base because I will show the invisible chain law. It has to get multiplied with the derivative of the inside value. So it turns out to be this. Base, 2 on the left side, sorry, -2 on the left side, -2 with a -1, times it by the derivative of the inside value. Inside value is whatever the value is powered with. The whole thing is powered by -2. So x plus 3 is the inside value. First derivative is being done, but the red part derivative is just a notation. We have to simplify that to finish the derivative. So it's simplifying the first term is -2 times x plus 3 with a -3 as the exponent. Derivative of x plus 3. Derivative of x is 1. 3 is 0. So invisible chain law, right? That one does not impact the result. So it's going to be -2 on the top. And on the down, this power, x plus 3, goes down. The -3 becomes +3. Another example on the right side, chain law is compulsory. It will be very hard to do it without the chain law. We have to simplify the whole thing. It's a very long work. So just make it fractionless. The whole power, the whole parenthesis with the power of -2, as we have done on the left side. F prime of that value is going to be -2 times the whole value, inside value with the power of -2, -1, multiplied by the derivative of the inside value. And this is the way we do it. I just changed the pattern so it's very easy to understand. This is the one. So we just fill up the blanks like this. Left side is simplified, will be simplified, but there is a derivative to be done. So it's -2 times the parenthesis with the power of -3. Derivative of 5x plus 3, the 3 is going to be 0. Derivative of 5x is just 5. So 5 plus 0. Now simplification. This 5 will get multiplied with the -2. So it's going to be -10 in the front with the parenthesis value of 5x plus 3 powered by -3. So simplification, we can't leave negative exponent. It's going to be -10 on the top. And 5x plus 3 becomes the power of 3. And it goes down. That's it. That's the final answer. I'm trying to introduce the chain law in a very simple way. The way I thought is simple. And I will be glad if it's simpler to you. So chain it by the derivative of x. When derivative of the inside is 1, we don't bother about that now. What about if we have a value, a parenthesis value with the power of 2? We have to simplify it. First, let's try to do it as a block. Derivative of a block or a group. But if we do it by this group, we need the chain law. So on the left side, I'm applying chain law. F prime of x is 2 times the whole group, the new exponent 2 minus 1, multiplied by the derivative of the inside value. So the inside value, I put it here. The whole group, 2 times the whole inside value times 2 minus 1 times just derivative of the inside value. So the left side is going to be 2 times x squared plus 4 with the power of 1. That value, we know it from the beginning. Whenever it's 1, we are not bothered. But if it's not 1, chain law has to be applied. Derivative of 2x is, derivative of x to the power of 2 is just 2x to the power of 2 minus 1. And that's a 0. So finally, it's going to be 2 times 2 is a 4. This value is just x, 2x, 4, 2 times 2, 4, times the x, times the parenthesis, x squared plus 4, done. On the right hand side, and we will have situations like that. That blue work is going to be done on the next video, on the next page. This page, one more example. I'm keeping the same example, but doing it without the chain law. It's only a power of 2, so it's very easy. I'm just applying either you can apply the FOIL or you can apply the formula. So basically it's going to be x times x squared. We have a 4x squared from the 2 middle term, 2 corner term, the foiling, another 4x squared, so it's 4x squared plus a 4x squared. And the right term is going to be 4 times 416. Simplification is x to the 4, 4x squared. 4x squared is 8x squared plus 16. Derivative of that, that's the basic one. See the size of the math, how big it's getting. We just simplified it. Now we use f prime of x. Derivative of the first term is going to be 4 x to the power of 4 minus 1 plus is going to be 8 times derivative of x to the power of 2 is 2 times x to the power of 2 minus 1, and derivative of 16 is 0. Simplification is going to be 4x cubed. 8 times 2 is 16, and that x is just x to the 1. Now they don't match because we have to factor out either we have to simplify the left side or we have to factor the right side. If I factor out a 4x cubed divided by 4x is x squared. 16x divided by 4x is a 4. Size of the math on the right side, size of the math on the left side, and we have just applied chain law. It's a very important example. It's the same example I've picked up from the previous page. Chain law is compulsory. Otherwise, we have to write the whole parenthesis times it 4 times. It will be a very, very extremely big work. Applying chain law, the whole thing is a block. So f prime of x is going to be 4 times the whole block with the power of 4 minus 1, but we have to chain it or multiply it by the value of the interior or the value of the inside. So this value will come up here, that value will go there. This way it's very neat and clean. So we just write this value, done. 4 times the whole value with the power of 1 short times derivative of the inside value. Left side is 4 times the whole value 2x squared plus 3x minus 5 with the powered by 3, 4 minus 1. All we do is do the derivative of the right value. It's going to be 2 times the 2, x with 1 short. So 2 times 2, that's the x, the 2 comes and it's going to be 2 minus 1. 2 times 2, x with the power of 1 short. Derivative of 3x is 3x, sorry, it's 3. Sorry about that, it's 3. Derivative of a constant is 0. Simplification. It's a big one, so I will just copy the left side factor. I will simplify the right side. 2 times 2 is 4 times the x is 4x, and it's a plus 3, 0, we don't need the 0. Now it's simplification. Now usually we leave this thing when it's factored, we just leave these things like this. We don't need to simplify it. Derivative has been done and it's neat and clean. Now let's learn something. We need it in the future. If you can just practice. We have done 3 steps, right? 1, 2, third step we got the answer. Was it possible to do it in 1 step? F prime of x, right? We have a 4. We have a whole parenthesis. We don't need to write 4 minus 1 one time. Remember, I've been saying 4 times the whole parenthesis, power is 1 short, 4 minus 3. Sorry, 4 minus 1 is 3. Chain it. First write the value. Chain it. Multiply by derivative of the inside value. All the work is on the top. Derivative of the inside from here or from here. 2 times 2, x 1 short is going to be 4x. Derivative of 3x, same thing, is just 3. 1 step is done. So you can rewind the video, we can save half of the time, more than half of the time. Just write it in one go and it's done. In this video, we're going to get trained. What if we see a 15 pi? In the instant, what is actually 15 pi? Pi is a number. It's just 3.14. Basically 15 pi, 20 pi or 500 pi is just a constant. So we know the laws. Is going to be derivative of the coefficient, which is 1/3, times the 3 times x with 3 minus 1, the first part. Second term is negative. The coefficient is going to be -5 times the x with -5 and a -1, plus the last part. Being the reason is a pi, derivative of 15 times pi is 0. And this is, simplify this too, and the rest doesn't get simplified. So this is 1 is just 1 times x to the power of 2, which is just x to the power of 2. Negative 3 times negative 5 is positive 15, and x with powered by -5, -1, -6. 0 is a 0. All we have to do is write the x squared, just simplify it using the exponent law. 15 is on the top, x to the -6 goes down with x to the power of +6.